In this video, let's try to understand how do we get the equation of a line. In one of the ways, you can say one of the equations of a line, because there are multiple versions of the equation of line. We look into any one of them. Okay, the basic version of the equation of line. Now, in this case, what we have is it's a very simple thing. Again, we start with the coordinate axis, the x and y axis, the coordinate axis. Now, here we have a line. Let's assume that the line is going like this. Fair enough. Now here we have angle theta. Now theta is the slope, correct? Now whenever we have this slope, the equation of the line has two important parameters. One is of course the slope. The gradient is very important, which we have discussed this in the last video also. The second parameter which is very important is the position of the line. Because if you look at the last video, three lines we wrote which has the same slope, correct, which has the same gradient, but each one of them they have a different position. So orientation can be the same, but the position can vary. That means the another parameter which is very important in defining a line is going to be the position. Now position is always with respect to the y-axis, or you can say it's actually with respect to origin, but then in the y-axis we calculate the position. See, we calculate the orientation, that is the slope, with respect to x-axis, correct? Same way, the position is calculated with respect to y-axis, in the sense where the line is cutting the y-axis. Is it in the positive scale or is it in the negative scale? That gives us the position of the straight line within the coordinate plane. So in this particular case, if you look at the line, the angle is theta. So slope m is equal to tan theta. M is tan theta, correct? Now here the line, so let's call, the points are there, correct, where it's cutting the x-axis, where it is cutting the y-axis. There are two different points. So let's call this particular point as C. In other words, we can write this particular point as C. Say this particular point is A. Fair enough. Now what we have here is that this distance and this distance, very important, very important. Now O to C, whatever the distance we have, that particular distance has a name, and this is called as y-intercept. This is called as y-intercept. That means y-intercept is the distance from origin on the y-axis where the line cuts the y-axis. Okay, again, let me repeat this again. Y-intercept is the distance between the point, that is the origin, and the point on the y-axis where the line cuts the y-axis. This is called as the y-intercept. And similarly, we have x-intercept. In our case, OA is the x-intercept. So this is the x-intercept. We have y-intercept and we have x-intercept. Now, generally, the x-intercept is along the, it will be along the x-axis. Y-intercept is along the y-axis. And y-intercept is generally given by the letter C. Okay, generally it's given by C. Now what we have to calculate what is the equation of this particular line, isn't it? Now let's try to do it with the help of slope. We know slope is what? y2 minus y1 by x2 minus x1, isn't it? Now point C, what we are looking at, C has a coordinate of 0 comma C, correct? And point A has a coordinate of x comma 0, whatever it might be. And the slope is given by what? This is equal to OC divided by OA. So M is equal to, now see, slope y2 minus y1 by x2 minus x1, isn't it? So what do we have here? C minus, so y2 minus y1, c minus 0 divided by 0 minus x. Correct? 0 minus x. y2 minus y1 by x2 minus x1. So now what do we have? M is equal to minus c by x. Or what do you have here? So this value m into x is equal to minus c, isn't it? Or mx plus c is equal to 0. Now what I want you to understand is we got mx plus c is equal to 0. Now if you look at this entire part, the whole thing, whatever we are going to look at, we are looking at y-intercept divided by the x-intercept, isn't it? Correct? And the equation of the line in terms of this y-intercept and the slope and the x-intercept, that using this particular equation mx plus c is equal to 0, we are going to get y is equal to mx plus c. Y is equal to mx plus c. Now y is equal to mx plus c is an equation. It is the general equation of a straight line. Okay, y is equal to mx plus c. Now how we are going to get y is equal to mx plus c? We have this entire part, m is equal to c minus 0 divided by 0 minus x. From this we are going to get the value, the x-intercept, the y-intercept and the slope. Okay, so y is equal to mx plus c. Now once you have understood this is the equation of the line, now for a line, three slopes are possible. Okay, let's discuss what are the slopes which are possible for a straight line. The first possibility, or you can say case 1. See, in case 1, suppose say slope is negative. Okay, slope is negative. That means we are going to have y is equal to minus mx plus c, negative. So in this, we have the x and y axis. Now the line, see here we have mx plus c. So it's above the origin, because whenever we have a plus c, it's above the origin. But if you have a minus c, it's below the origin. Okay. So we have y is equal to minus mx plus c. The line goes like this. That means if you look from left to right like this, the line keeps on decreasing. So whenever there is a decrease in the line, then we say that it's a negative slope line. So in this case, what we have is m is less than 0. So we can also call it as a declining graph. Declining line, declining graph, you can call it whatever it is. Got it? Now the second case, case 2, is where m value is equal to 0. That means we have y is equal to c. So in this case, now this is a line which is parallel to x-axis like this. Okay, it's a constant line. So in this case, this becomes a constant line. It's neither increasing nor decreasing. It is constant. So this is where we have m is equal to 0. So I think you guys would have guessed the third one. Third case is where m is greater than 0. For this case, case 3, where we have m greater than 0. So we can say y is equal to mx plus c. So in this case, so now you have 0x and y. We are going to have a line like this, where we have a positive slope. Correct? This kind of line is an increasing line, because if you go from left to right like this, the line keeps on climbing, isn't it? So this type of a line is what we call as ascending line. Okay, it's an ascending line. Now, these are the three types of slopes which we can define. There is one more light type of line where the slope is not defined for it. What if theta is 90 degree? What is tan 90? Not defined, isn't it? So, for a line which is parallel to y-axis, the slope is not defined. For a line parallel to x-axis, slope is 0 because it's a constant line. Whereas for a line parallel to y-axis, the slope is not defined. Fair enough? That's why whenever we talk about the slopes, we always talk about three types of slopes: positive, negative, zero. That's all. Clear? So these are the type of slopes, and that's the equation of the line, one of the equations of the line. So in the next video, we'll look into what if two lines intersect. How do we figure out the angle between them? How do we figure out that two lines are actually parallel or perpendicular? We'll look into all these things in the next video.